about parallel rules. And in order to solve circuits, parallel circuits, I need to use the parallel rules. And the simplest way to do that is to know the rules. Now, short of memorizing these rules, here's a trick to make it easier. I'm going to draw a parallel circuit. I know that a parallel circuit looks like this because all resistances feel the full resistance of, or all circuits feel the voltage. So if I say this is 12 volts, this is going to feel 12, this is going to feel 12. So that makes it a parallel circuit. I'm going to give this some values. We're going to say 2 and 3 amps. I'm going to switch colors here so I don't get myself confused. Okay, so we have 2 and 3, no, those aren't amps, those are ohms. We have 2 and 3 ohms. Now I'll switch. So we want to figure out the amps for this. So we want to look for I for each of these, because each of these, there's a certain average that goes through here and a certain average that goes through there. So to figure it out, I want to know what I equals. So if I draw my triangle, I'll draw it down here, E equals IR. So I need to know what I is, so it's going to be E over R. So we have our E, 12. We have our R, 2. That means 2 into 12 goes 6. 6 amps flow through this spot. Okay, so once again, to reiterate, the current in all parts is a product of the voltage divided by resistance. That's what we're doing. So I'm going to do the second part, but it's a 3. So 3 into 12 is 4. 4 amps. So I've got the average. Now, to get I total, I'm going to add those together and get 10 amps. The rule says the current in all paths is a product of voltage divided by resistance. So we've done that and we've got 10 amps. So we've figured out number 2. Voltage, number 1 is voltage is felt at each resistance. Number 2, all the amperages add up. Oh, we haven't done that one. That's number 3. Number 3 is all the current is the sum of the individual currents. So we've added them together to get 10. I've already done rule 3. I jumped ahead. So that's the first 3 rules. The next rule is adding resistances to parallel. So let's add another resistance. Decreases total circuit resistance. So there's more current can flow in this because we just decreased it by adding another one. And then the following rule, subtracting resistances, increases resistance in the circuit. So those are pretty easy rules. The third rule is the easiest of them all. The third rule is a check. So what I have to do is I have to figure out what the resistance of this parallel circuit is. That is a unit, and the resistance is going to work together. So what I do is I use a formula. I think I'm just going to clean this off to make it a little easier for us. And that was 10, so I'll just put it in here so I don't forget. 10. So what I have to do to figure out the resistance of this circuit, whatever it's going to be, it's got to be it's got to be smaller than 2. So let's see if it is. So I use 1 over RT equals 1 over R1 plus 1 over R2, and if there was more, I just go 1 over R3, 1 over R4, but there's only 2 here. So let's replace these. So 1 over R1 is 2, so it'd be 1 over 2, so we'll get rid of that. And on this one, it's 3, so we'll get rid of that. 3 and 1. Now, we can't add these together because they have different denominators. So they both will go into 6. I can figure that out really quickly. So what times 2 is 6? It would be 3. So it will be 3 over 6. You can get rid of that now. What times this equals 6? 2. So 2 times 3 is 6. 2 times 1 is 2. There. So now, where 1 over RT equals 5 over 6. To get rid of the 1, we have to flip this over. So when you flip it over, you get RT. We got to flip this over too. So we got 6 over 5. 6 divided by 5 is 1.2 ohms, or a lot of times we just use this little guy. 1.2. The smallest resistor is 2. Total resistance is less than the smaller resistance. I believe it worked out. The rules, once again, voltage is applied to all paths the same. This will all field 12. The currents are a product of E over R will give you I for each area. Then they're added up together to equal total amperage in the circuit. Adding another leg will decrease the resistance in the circuit because one more conductive path. Subtracting it gets rid of a conductive path, so it increases the resistance. And finally, once we know what the resistance is, it's got to be less than the smallest resistor in the circuit.